So yeah, so this is about automation with JMRI scripting. So this, just shows various elements that go up to make a whole automated system. Let me just put the pointers up. Here we go. There we go. So what I'm going to go through roughly, a quick run through my layout, the hardware that I use, and I'm going to demonstrate it by means of a few short videos. And then a brief overview of JMRI and how it fits with MERG, a look at the control panel in JMRI, and I'll try and go through all this fairly quickly because I want to get to the scripting bit as quickly as possible, which is the bit that the title of the presentation, and a little bit on about how to stop a loco accurately, because when I've spoken to people about this before, this is something that always seems to be of interest, so I put in a few slides specifically on that. And by accurately, I mean stopping it in a specific location. Okay, so this is the quick view of my layout at an early stage of construction. So I've been doing this for about 4 years. That's when I first started it. And from day one, I've had automation in mind. I've always wanted to build it to be able to automate it. So it's been designed with that in mind. So the idea was to get as much operational interest as possible in the smallest space. So I did it in Engage. It's about 1 meters by 3 meters, split across 2 boards. And just to give you an idea, there's about 30 turnouts. Well, there are 30 turnouts, and I've currently got 25 DCC locos on there. So it's quite a lot to play with. Basically, it's just roundy. There's 4 loops going round, 2 in one direction and 2 in the other. And then there's various crossover points and sidings and a turntable and so on, as you can see. So there's lots of things to play with, automation-wise. And just to show that I have done some modelling as well, just to prove it's not just about the automation. So this is what it looks like underneath. So it's entirely based on MERG hardware. Apart from some relays, I don't use anything else. So it's C-bus based. So I've got a CAN USB, I've got a CAN command for the DCC controller. I use the DTTC8 occupancy detectors plus the feedback module onto the C-bus. I use the ACC5 for the point motors with Cobalt analog IP tortoise slow motion point drivers. I use a CAN LED or a number of CAN LED 64s to drive all the signals because it's fully signaled, and I use an accessory driver to drive the turntable relays. And this is what the 2 boards look like underneath. The little black things you see are basically little rubber feet, which is useful actually for putting it down and let air underneath. But the other reason I needed them is when I didn't realise the tortoise Cobalt motors were going to be so big, and actually they hung down beyond the bottom of the board. So I had to put feet on anyway to raise it up. And I drive everything directly off DC supplies. I don't derive it from AC or anything. So and there's 15 volt, 9 volt and 2 5 volt supplies. So that's briefly what the hardware looks like. What's perhaps more interesting is what I've decided not to do hardware wise. So the first thing is I decided not to put in any spot detectors. And I deliberately did this because I wanted to do as much as possible in software rather than in hardware, just to prove really that I could do it rather than any other reason. Basically the hardware tells me when a block has a loco in, but I've no idea where it is in that block or when where to stop it at the end of the block. And the stopping location is determined by the scripts, and I'll be talking more about this later on. And as it says there, it is difficult to implement and it's not always precise, but I'll go into more detail on that later. It's quite a difficult thing to do, to get a loco to stop in a particular spot without having a spot detector. It's not easy. And the other thing is there's no axle loads. So something like a DMU with rear lights, it draws current, so you know when the end of the train has vacated a block. but obviously if it's a loco pulling rolling stock, then the rolling stock doesn't draw any current. So you don't know when the train has exited a block. You only know when the loco has exited the block. And actually it's relatively simple and actually quite accurate to get around that in a script. So you can make it look as though the end of the train has got a load on it. And again, I'll talk about how that was done. So, but this was just my decision. I decided to do is not to do this, then it gave me more options for playing around with what to do in the scripts. Yeah, just to say thanks here as well to everybody who's to do with the design and the delivery of the kits. The quality and the support through the forum and everything else has been very good, and the reliability has been superb as well. Once you built it and got it working, it just works. I don't have any issues at all, so it's very, very good. A couple of things I will mention, just in case it's of interest to anyone else. When I first put in the turntable, because that was added at a later date, I wired it to the same 5-volt supply as the track detectors, occupancy detectors, and the track detectors all stopped working when the turntable worked, because presumably because the turntable generates so much noise on the supply that the little voltages, the tiny voltages that the detector's trying to pick up was just lost in the noise. So very easily rectified. I just put in a separate 5-volt supply for the turntable and it was all fine. And the other thing, just in case, I don't know if anybody else has done this, but it's been on the forum, I think. I managed to fry quite spectacularly my C-bus transceiver on the USB board. And I think the reason it happened was because I power the CAN USB off the USB port rather than from its own supply, and I hadn't tied all the grounds together on the board, and therefore the voltage difference across the C-bus got enormous at one point, and it actually spectacularly went up in smoke, and actually you partially melted the socket in the on the board as well. It got really hot. So if anybody's thinking of doing that, just make sure you tie all the grounds together so you don't have that problem. Okie doke. So what I'm going to do before I talk any more about JMRI or any implementations, I'm just going to run a couple of short videos so you can see what the end result is, and then I'll talk about how I've actually gone about doing it. So here we go. I'm not sure videos, I'm just pausing it for a minute. Videos don't always play that well over Zoom, but hopefully this will. So I'll just set it off and then I'll talk about it as it plays. Yeah, let's wait for all the horns to subside, the loco's setting off. So basically what we're looking at are these 3 lines on the left basically go into 2 lines down here, and then there's various crossovers and things. So we're just looking at the motion of the locos as they run through this crossover. So you can see it's fully signaled, there's green and now it's gone red as the train goes through. So that train having gone through, there'll be another one through in a minute, hopefully. There we go, yeah. It does get a bit more interesting as the operations go on. So they're all red lights at the moment after this loco's just gone through. And there we go. So there's another loco now waiting to go. You can see the points there's just changed because it's going to go all the way across, but it's currently sat at a red light because the previous loco hasn't cleared the next section. And as soon as it does so, the light will go orange. There we go. And the horn fires off and the loco sets off. Okie doke. And then what should happen is the next loco should arrive. There we go. So he's having to stop, and you can see the point set against it. It's just changed, and then it's still got a red light because the previous loco hasn't cleared the section again. And then when the next section goes, is cleared, that should go amber, and then it should set off. There we go. And it will set off, and then this one will have to wait at the red light. And what you'll see once this train has cleared the points, once it's gone past, you'll see here, if you look at this point here, you'll see once it's been cleared, then it will change, ready for the next loco. Any second now. There we go, so that's just changed, and then we've still got a red light, still waiting for the loco to clear the next section. There we go, it goes amber and off it goes. So the way this is working, it isn't like a choreographed set sequence of movements. Each loco is actually moving independently, but is reacting and is aware of all the other locos around it and everything else that's going on. So I can randomly set off different locos on different routes, and they'll all run around quite happily, and when they need to interact, they'll stop or whatever they need to do. So that one goes on, and then the next one. So it sort of gives a basic idea of running through a junction where there's a conflict, where all the locos you know, come together. Okay. The other thing I will say is the other thing you probably heard was all the horns and things going off. That's not done with sound decoders in the loco. That's also done by the script. So it's pretty simple. Basically, I've just loaded in a load of horn samples into JMRI, and then every time a loco starts off, it plays the appropriate horn sound that's assigned to that loco. Okay, if I can just close that down and then have another look at turntable working and a few other things. So talking about sound again, I've taken it one stage further with this class 20 here, which is going to move on to the turntable in a minute when I start the video. Basically, this has got full sound defined. So what I've done is sampled a whole load of class 20 loco noises, and the script knows whether the train's idling, whether it's accelerating, whether it's slowing down, what speed it's going. And then I've synced JMRI to play the appropriate engine sound depending on what the loco is doing, and you'll hear that hopefully in a minute. The other thing you can do, you can also not only define the sound, but you can define where the sound's coming from. So you can pan it left, right, or front, back of the layout. So you can make it, to a certain extent at least, make it sound as though it's coming from that actual loco. So hopefully so that'll now go onto the turntable. So you can see here there's a number of different things going on. There's trains coming out of the sidings, there's a train on the turntable. So you can have lots of different things going on at the same time. Point motors are rather noisy. So this train's now having to sit here and wait until this this one's cleared out of the way before it can join the main line. And you can see there's another train coming out now in the background. This is all automated, so I'm just holding the camera while I'm doing this video, so I'm not touching the keyboard at all. And hopefully you can hear that one's now moving off. So as soon as this one's moved off, the turntable's going back now to pick up this loco, which is going to move from position 2 to position 1. And in the meantime, this thing's going off and going to sit in a little head shunt, and all the other locos are running around the layout at the same time. So there's lots and lots of different things all going on at the same time. And every loco will just run independently, doing its own thing until it comes into conflict with something else, and then it will react to it. Yeah, so that's now finished. This loco here, you can see with the tankers on, is now finished doing its roundy, and now it's just going to put itself back into the siding where it came from. Again, this is totally automated. I don't touch anything to tell it to do that. Next train's coming round, having to stop because the point's against it. And you can just hear then the point change, so now it can come on through. If you just take it all the way to completion, if I just drag the, accelerate this a bit so we go to the end, you can see the last train just reversing in. So that's sort of a bit more manic example where there's lots of things going on at the same time. And it's all totally automated. You probably notice here the layout's a bit smaller than I showed you before. It's because originally it was on one board and then I extended it and made it onto two. This is an old video from when it was on one board. Right, so if I can get rid of that one and show you the last video. So this just shows sort of a flexibility of doing your own scripting, really. What we're looking at here, you can see the three sidings on the right. This one here has got three locos and a DMU in it, and this siding has only got one block occupancy detector in it. So what I've done is actually I've written the script so that it will actually handle multiple occupancy of the same siding. So what happens if I just set this off and we watch this loco disappear from view? What the script does is it knows exactly what's in the siding, and what it will do, as you'll see, is shuffle them all up so that they allow room at the other end for whatever next loco wants to come in at the back end. So the first one's gone, and there goes the second one, and then you'll see the back one will light up. The light will come on in a minute when it activates, and that will move forward as well. There we go. So that will shuffle up. It's not very prototypical, but it's very useful to be able to do this. It just shows the flexibility you have once you start scripting. And then when the loco comes in the other end, it knows the sidings are already full, so it will just stop as soon as it comes in right at the back end. If there were less locos in there, it would have stopped further up. So they're just three quick examples that show you know, the scripting that I've done and what it actually what it actually achieves. It's quite difficult to capture it as videos. It's much easier to do to actually show it in front of the live layout, but it gives a feel at least. Okay, so back to the PowerPoint, I'm afraid. So why did I do it? Well, as you can see, basically because it gives you full control over the layout. You can get it to do exactly what you want. And that really was my motivation. I can just tweak it and all the little subtleties, you can make it do whatever you want. So JMRI, I'm going to go through this very quickly. This is just the JMRI web page, the front page that you get if you go to jmri.org. And what I wanted to just point out is that it's split into 1, 2, 3, 4, 5 different applications. There's Decoder Pro for programming your decoders, Panel Pro, which is for building up and running your control panels, and you can also run scripts in there as well. Then there's Dispatcher Pro, which gives a whole load of tools for actually running your locos. If you don't want to write scripts, JMRI provides a lot of tools for running locos yourself, and also Operations Pro, which is also for running your own trains, and then Sound Pro for obviously playing around with sound. And this is the bottom half of the JMRI web page, so lots of stuff in here, information. And here they've listed everything by tool. So you've got tools for timetables, you can see here, tools for sound, tools for signaling. It's an absolutely vast tool. I only use a very small part of it, but it is a vast tool if you want to look at it in detail. This shows all the different hardware systems that are supported, so it's very, very well supported. And obviously CBus Merg is there, and if you go into CBus Merg, there's a whole load of documentation on there about how all that works if you want to have a look at it. If you install JMRI, it's very easy to set it up with Merg. Basically, there's in the preferences frame, there's just two forms to set up. You tell it that you're using Merg as the manufacturer, you're telling it to use a USB, and you tell it which USB port you're using, and that's it. And then if you want to use the throttles for DCC control, you tell it in the defaults here that you're using Merg for the throttles. And that's all you have to do. Once you've done that, it's set up, ready to go. This is another example of the Merg integration. There's a Merg menu inside JMRI. And this particular, what I've done here is just shown the CBus console. So you can actually see messages here flying up and down the CBus within JMRI. So it's very, very well integrated. What we're seeing here actually, I think, is the background chatter between the CAN command station and the JMRI throttles. They're constantly talking to each other with these keep alive statements, even when they're not doing anything. And you can see all these messages on the CBus if you bring up the console. There's lots of other things you can do as well, but I'm just picking out one example to show that the Merg integration is very good with JMRI. So the next thing is, once you've set up JMRI, you've got it linked to your CAN USB, and you've got the throttle set up. The next thing you need to do is create JMRI objects for all of your CBus events. So in the top, but in what they call these tables, the JMRI tables. So at the top here, you can see this is the turnout table. And so all I'm doing here is saying CBus event 374 is assigned to a turnout, which I've called E4S3A. So when I send out, so JMRI now knows that if I close or open point E4S3A, what it will do is it will generate CBus event 3474, and event 374 is what I will have programmed onto the point controller using FLIM. I assume everyone's familiar with CBus events and programming CBus events. This basically links your CBus event to your turnout in JMRI. So you set up turnouts same way you set up sensors. So basically I will have programmed my sensor, which is on a block I've called E3. So when E3 goes active, it will basically send out event number 157 on the CBus, which is what I've told the program the sensor to do. And then this is just assigning that object with that event. And you can see here it also tells you whether it's inactive or active or thrown or closed here. So it basically, all the tables do is it links the CBus event number to the JMRI objects. It's a bit tedious to set up, but you only have to do it once. You can also set up things called lights. I presume they're called lights because originally they were used for controlling lighting. But basically, this is where you set up where you're driving any accessories, basically. So in this case, CBus event 501 turns on the turntable power, 502 toggles the direction. And in fact, just again to show the flexibility of the system, because I added the turntable at the end, I only had two, and I found I only had two spare channels on my DTC8 for the block sensors. and I actually needed 5 sensors because I've got 4 radials and 1 turntable, so I needed 5 sensors and I only had 2. But because I had spare capacity on my accessory driver and I had spare relays on my relay board, what I did was connected these 1 sensor to the turntable and the other sensor to 4 of the relays, and I actually share the 1 sensor between the 4 radials and switch it using the accessory driver. So I was just reusing the hardware I had. So it's just, again, another example when you start playing around setting everything up with your own scripts, the flexibility you can have. The final table here is the signal heads. So in here I've got a signal head called E2, and it's a 3-aspect signal. So it's got 3 lamps associated with it. So these are the MERG C-bus events which drive the green, yellow and red lamps connected to the CAN LED board. And you can also have signal masts, so you can have you can have 2-aspect, 3-aspect, 4-aspect. There's lots and lots of different signaling systems built in. I happen to use a 3-aspect signal, and you can have lots of different masts with multiple heads on different masts. And there's also a utility here which I will talk about a little bit, which is you can use for generating all the signal mast logic. So you don't have to write your own signal mast logic. JMRI will do it all for you, and I'll talk a little bit about how that's done. Final thing I mentioned down here, because it ties into the presentation from last month, is also, you can see down here there's Railcom IDs as well, if anybody's going that way. Okay, the other thing you can do in here is what's called a logics tables, if nobody's seen these before. So basically in here you can set up a logical expression and an action. So for example, you could say if signal mast E3 is set to red and logic sensor for block XYZ is set to active, you can set that as a condition, and then down here you can have an action that you're going to perform, which might be set the turntable going, or set a level crossing barrier going or something. So you can actually set up actions without writing any scripts. You can do it in this table. You can set up a condition and an action to be performed, which is basically what the scripts are doing, but you can do it in the table without writing any code. And it's quite useful. So if you just want to do that, then that's fine. And you can see there's an OR operator. You can have OR and whatever, but very useful. Right, the next thing I'll talk about is the control panel. So everything I've talked about and I'm going to talk about from now on is within the Panel Pro tool. So you saw all the tools listed before. The only one I use is Panel Pro, within that you can create your control panel. As is typical with JMRI, there are lots of different tools for creating the control panel, not just one. There's a layout editor, there's a panel editor, there's a whole list of different tools you can use. This is using a tool called the layout editor. So basically what you do is you draw a piece of track and then you assign a name onto it, which is the name of the block sensor that you set up in your table. And as you can see, if the sensor is active, it goes red, and if it's not, it goes black. And you can also assign a block value onto the sensor as well, which carries the name of the loco, and that moves around. As the loco moves around, you can see the block values move around as well. Then you would create your turnouts, and again it's exactly the same. You just add a turnout from the menu, sign a name onto it, which is whatever you assigned in your table, and you can then actually, if you click on the turnout, it will actually drive the turnout on the layout. So this isn't just for feedback, you can actually drive the turnouts from the panel here as well as see the state of them. And then the next thing to do is to add all the signal masts. So you can see them all here populated around looking like lollipops. So basically at the beginning of every block, I would add a mast. And once you've added all the masts, you can then tell JMRI to generate the signal mast logic. So based on how you've drawn the panel and where all the turnouts are and where all the blocks are, it will generate all the signal mast logic for you. You don't have to do that yourself. Basically, if you have as you have here, if you've got a turnout that's set against you, you're going to get a red mast. If you've got a block that's occupied, you're going to get a red mast. And if the turnout is set correctly and the block isn't occupied, then the state of the mast is set based on whatever the next mast is down the line. So you can see here, for example, you've got a red mast and the next one's amber. But it does all that for you. You don't have to write your own signal mast logic. It's all extracted from the panel. I will say it's great once it's working. It's very reliable. It's 100% dependable, but it is a bit of a pig to get it working in the first place. There are some very strict rules on how you've got to draw the panel to get it to work, and it is a bit fiddly and finicky to set it up. So I had a few attempts at getting it working. But once it's working, it's very, very good. It works 100%. So that's the control panel. And you can also in JMRI set up throttles. So this is an example. You can obviously have all the functions and the direction and so on and so forth. I will mention very briefly as well, there's a web server that you can run in JMRI. And basically what that does is that every JMRI window then goes into a separate tab on your tablet or smartphone. So you can then run the control panel and all the locos directly from your tablet or smartphone if you want to as well. So finally, sorry that took a little while, but I think it's essential to have that background to make sense of what's to come next with the scripting. So the language is called Python, and basically it's basically the same as Python, and Python is an industry standard language for those who aren't familiar with it. The best way to get into it, there's loads of resources here as you'd expect. One of the best ways is to just go and have a look at all the examples here that are on the website, and it's very often it's easier to start with something somebody else has done and tweak it than try and do it from scratch yourself. And there's lots of examples. There's also JMRI Yahoo IO group where if you're stuck you can post questions, and generally within an hour or so if you post a question then somebody's going to reply, so that they're very, very helpful. And also, of course, there's a wealth of knowledge on there, because if you're going to ask the question, the chances are someone else has already asked it as well, so you can get help from there. These show some of the tools that are available to you. So you can, there's a script entry window, so you can just literally type the Python directly in the window and execute it. You can obviously put it in a file and load it. Then there are two output windows, one for system messages and one for user messages. So the system messages would be for things like syntax errors or anything JMRI doesn't like about the code that you're trying to run. And user messages is just where you can put print statements yourself in the code and then print out messages to help you debug what you're doing. And the other window in here is a thread monitor. So every time you run a new piece of code, it basically runs in a new thread, and you can get a list here to see all of the threads that are running. So when you saw before I had loads of trains running all at the same time, you would see there'd be a thread entry here for every train that was running, so you can just monitor what's going on. So this is an example of a JMRI script, very simple one, just a few lines, but it does introduce a lot of the key concepts. So it's a very simple script. All it does is sets off a loco, and when it enters a particular block, it stops it again. So first line, this is a complete script, so I'll just run through it line by line to try and explain the structure. So the first line just imports JMRI functionality basically into the script so you can use it. Then you have this concept of a class. So a class basically doesn't run the script. It's basically just defining a piece of code that you can then use later on. So the way it describes it on the for sort of non-programmers, the way it describes it in the JMRI website is it's like you're building a row of houses, and this is like the blueprint for the house. And every time you build it, you actually put a house down, that's when you instance the code or run the code. But this just defining the blueprint for the house, or the blueprint for the code. It's not actually going to do anything. It just defines a piece of code that you can run basically. So that's what a class means. Then you have these two def statements as def setup and def handle. Basically, def setup is just run once. So anything you want to do to initialize the code you would do in here. And then def handle is run continuously. So basically anything in the handle runs, you can see it gets to the bottom and it says return true. So it does what's in the handle, goes back to the top, goes to the handle, blah, blah, blah. So it keeps going round and round and round, which is what you want for automation because you're constantly monitoring what's going on. And then once the code's finished and met its condition, when it finishes, you say return false. So then it exits. Sleep is fairly obvious. It just pauses the code, in this case for 100 milliseconds. Otherwise, it would just free run and take up 100% of the CPU, which is, not what you want to do. So basically, this piece of code will be repeated every 100 milliseconds once you've set it off until it meets the condition when it stops. The other thing you can see in here, you've got this self idea in here. So self.loco, self.blockname, and so on. And basically what this does is it says it holds the contents of the current instance. So you can see here you're passing in the throttle number and the block name as arguments into the code. And when you run this, basically what the self does is it self.loco will apply to whatever throttle number you've passed in. So if you can imagine you wanted to run this twice for two different locos in two different places, then when you set it off for loco 1, then self.loco would apply to loco 1. When you set it off for loco 2, self.loco applies to loco 2. So what it means is you don't have to track yourself what's going on with loco 1 and what's going on with loco 2 by having a whole, a variable for every loco. You just have whatever is the current loco that is running this script, and that's what this concept is of these self.loco and self.blockname. And I didn't, when I first started scripting, I didn't fully understand that, and what I was actually trying to do, I had a loco _3, loco _4, loco _5. I was trying to track every loco myself in the script, and you don't need to do that. The script is generic and it will apply to whatever loco is running it, and that makes things a whole lot easier to set up. And just to complete it, I've just in the hashes here shown what these do. So self.get throttle is obviously picking up the throttle for whatever throttle number that is. The false just means it's short addressing. That sets the direction, that sets the speed. And then basically if this sensor is state 2, which means if it's active, then set the speed to 0. So it's a very simple script with just a few lines, but it does introduce a lot of the concepts of how you structure the code. So if you want to run the code, as I said, it just defines the template for the code, and this is the code you would put in to actually run it. So you basically, my example was the name of the class that I defined in my code. So I'd run the setup, pass in the number of the DCC address of the loco and the block I wanted to stop at. This just sets a name, so when you look at it in the thread monitor, you can define the name for the thread monitor, and then you start it. And And obviously it's not very convenient to actually type all this in. If you wanted to actually use this piece of code, you generally want to do it through a GUI. So this is an example of how you'd build a GUI. I won't go through everything because I haven't got time, but basically the GUI has just got two pull down lists, one for the loco number and one for the block. So the list of throttles available is defined here, the list of blocks defined here. And then you can see here there's this thing called JCombo box, which is just a Java X swing construct that builds the list of locos in the GUI. This builds the block list. And then you build an apply button, and I define an action for the apply button, which I've called here CB Select BA. And CB Select BA is down here. And what CB Select BA does is picks up the train name and the block name and sets off the script. So that's how you'd build a simple GUI. So the final part, or nearly the final part of the presentation, is for a more complex example. So how would you actually use that to actually automate a layout? And I'm not saying this is the only way to do it or the right way to do it, but it does illustrate how I've decided to do it. So if you have a simple layout like so assuming the trains are only ever going to go clockwise in this particular case, and obviously you've got a loop with another loop inside and some turnouts. The naming convention is fairly obvious. Just one I always stick to is compass points, and then just going from 1 to 2, going from outer to inner blocks, just so you can, from the name of the block, you can then tell exactly where it is just from its name. So what I'm going to do is go through a pretty much complete example of how I would write something to set off automated trains like you saw in the videos on this layout. So basically what I've done is I split the code into two files. There's what I call a definitions file and then a generic piece of code. So the definitions file basically describes the layout topology and the attributes of the locos and so on. And the operation code takes its input from the definitions file. And you'll see why as we go through that it makes sense to split those two things out into separate files. You could kind of hard code that particular layout into the script, but to me that's not the way to do it. Makes much more sense to separate out the generic operating code from the specific topology of the layout, and you'll see why as I go through. And as a side effect of that, basically it means potentially somebody else who had a layout could pick this up and just tweak the definitions file and run the generic code on their layout. So, and as it says here, this is just a simple example to show the principles. The code I actually use uses the same principles, but it's got a lot more features, and I can't remember how many lines of code it is. It's probably so 3,000 or 4,000 lines of code probably now. The other thing I will mention, which is worth a look, is there's a thing available on the JMRI user group called YAAT, which stands for Yet Another Auto Train, written by a much more competent user than I am. And it uses the same principle of a generic operating code and a configuration file. But in his case, what he's done, his programming skills are way above mine, and he basically takes I think he extracts the topology of the layout from the control panel rather than defining it in a config file. But his configuration file, basically what you do in there is you specify in what virtually looks like English, a description of the operations you want the layout to do. So you say move train A from position X to position Y, and so on and so forth. And you basically write your operations that you want in a very English-like structure, and then his script will take that and interpret it into JMRI operating code and actually run the layout. It's really very clever. And so if you were going to look at JMRI scripting, it's probably worth having a look at that. All the source code's there as well. So it's a very good example of showing the sort of complexity of what you can implement with JMRI. So I would recommend looking at that. Lots of people have tried to do this sort of thing, writing automating scripts, but this I think is one of the better ones. So this is my definitions file. So use your gobbledygook at the beginning to import the JMRI stuff. I'll just mention this in passing. Basically, all this does is when you exit JMRI, it remembers where all the locos were, and this line here just forces it to read all those block values back in again. So the operating session will just carry on from where you left off. So the next bit, this is where I define the topology of the layout. So here, for example, I've defined something, this is just a list called E2S1. So this defines everything that the script needs to know when a loco's moving from block East2 to block S1. So it needs to know the name of the current block, the name of the next block, the name of the mast at the end of the block, the name of the turnout, and the state that the turnout needs to be in. And the same you can see here, for example, another example going from north 1 to east 2. So that would be from this one to this one. And the difference here is there's actually two sets of points defined, because it not only sets this set of points, but it also sets the one ahead as well. So it looks ahead. It sets the next point and the one ahead as well, which is useful because it just keeps things moving much more smoothly if it sets not just the next one but the one ahead as well. So this just defines all the information that's needed. If you've got a train in this block and it wants to move to this block, this is everything the script needs to know. Okay, and the next thing you do is then define the routes. So if I want to go from north 1 to north 1, which is be from here around the outside and back again, basically this is the string of sections or transitions that you have to go through. Okay, and so the transitions as defined on the previous slide. So it's just a list of lists basically. And if I wanted to go from there to there via the inner loop, then basically it has to go around here, around here, around here, around here, back around the outside. So it's obviously a much longer list. So what happens when you've got set your thread off and your train is here, it's going to be looking at everything in this entry. And then as soon as the script has detected that the train has moved to the next block, it then picks up the next entry in the list and operates on everything in there. So which is why you can see it makes sense to partition into generic operating code and a configuration file, because you can just keep reusing the same piece of code for every block. So, and all it does is takes the information for that block from the list that you've given it. So it's much better than trying to hard code, I think, the topology of this specific layout into the operating code. It makes sense to separate them out. So what then happens when you run two trains at the same time? Then obviously you've got one train here, and everything that's running in the first thread is applying to taking its information from here, and we've got another train here which is currently in north 2, so it would take its information from whatever's in this list. So you've got the same piece of code running in every block, and also the same piece of code is running for two different trains as well. So the same piece of code is run over and over and over and over again, just picking the information it needs from this definitions file. Now this also begs the question, what happens because we've got two trains here, and this train will be saying this point needs to be set straight through, and this one saying it needs to be set switched. And if I didn't do anything, this point would obviously just dither. It would keep toggling between, these two would be arguing, and one would be setting it one way and one the other, and it would just dither between the two. So obviously you don't want that to happen. So this is an example of where I said the threads are running independently, but they have to be aware of what each other's doing, so you don't end up with this situation of points arguing or a collision when the two trains come together. So this introduces this idea of basically using a global variable that both of the threads can see. So what I do is set up a thing called a dictionary. So I define a list of points, and then for every point in the list, what I do is I assign an entry in the dictionary with that name, and I say that, just to say that that point is free. So that's what happens initially. And what happens when these two locos come together? Remember, we've got two threads running. So anything that's south.loco in this thread refers to this engine. Everything that's south.loco, it's the same script, it's the same variable name, but it's running in a different instance, and it refers to this loco. But both threads have got read and write access to the point lock states, because the point lock states are global. They're not specific to one thread. So obviously what happens within the script, when this train comes along, if this one comes along first, what it does is it goes to this list of point locks and it stamps its name on the point lock, which means that that train now owns that point. And when this train comes along, it'll test to see whether the point lock is free. And if the point lock's not free, it will stop and wait. When this train's passed, it will release the point lock, and then this one will then see it's free, grab the point lock and change the point. So this very simple mechanism of having a dictionary of global variables basically is the means by which the trains can communicate for cases where they come together. For example, where they're arguing over who has control of a point. Final thing is, I said I've got no stop detectors. So this is how I manage trying to stop a train in a specific location. So first thing I do is I only allow the locos to run at one of three speeds. They either run slow going up to a red light, medium going up to an amber light, or fast going up to a green light. And what I do within the definitions file is define the amount of throttle that has to be applied to make it run at that speed. So if a loco is approaching a red light, I know it's going to approach it at the same speed as any other loco. So loco 5 requires 14% throttle to run at slow speed. Loco 9 requires 8%, and loco 19 2.4%. So if I apply that throttle to that loco, I know they're going to run at the same speed, and the same for the medium and the same for the fast. What I then do is define a delay for each section. So basically what happens in the control script, which was reading all this information, when a loco enters a section that's got a red light, it will slow down to its slow speed, and then it will run for this amount of seconds at that slow speed, and if the light hasn't changed, it will then stop. So you can see obviously there's different values of delay because the blocks aren't all the same length. You can see some are twice as long as others. So I know if a loco enters a speed block, I know how fast it's going, and I know if I run it for that set speed, for that set amount of time, it's going to stop in the same place as any other loco. And that's the basics of how I get it to stop in the right place without having a stopping detector. Now in reality, it isn't that simple. There's a lot of complexities which make this not work, and I've got a couple of slides on that later on. In fact, it's coming up very soon, which show why this doesn't work in practice. But that's the principle of it: running a loco for a set time for a known speed to get it to stop in the right place. So this is just, all this is doing here is defining, referencing a name to a number, so that when I use the locos, I can refer to it by its name rather than its number. That's all that's doing. I won't go through this in detail, but as we saw before, this is exactly as we saw before. This is just building the GUI that I use to actually run my script. So I just select a loco, select a route I want it to go on, select its direction and how many times I want it to go around the loop. And then, as before, this is the callback event. So when I execute that form, what it does is it just then runs my setup and runs my start, which actually starts the thread. And the final bit just down here for completion, this is just a piece of code that builds all the throttle windows. So you can have all the throttles. You don't have to open those one by one. You can get a script to open all the throttles for you as well. So that file is actually complete, and it with the control file that runs the script, that will actually run that layout. So you can pick a loco, you can pick a route, you can have multiple locos running around, and they will run round doing exactly as you saw in those videos. I'm not going to go through the control script because there's not time, and I'll just say basically how it would work. So the control script to go with that config file. So the config file defines, when you have a loco in a block, it defines the name of the block, the name of the mast, the name of the turnout at the end, and the stop time. And all the control script will do, it will know what block the loco's in, it will read the mast, and then set the speed based on the speed of the mast. So you can see here it's red, in which case it's going to have to stop. And if the turnout is free, it will set the turnout. And then as soon as the mast goes to a state which allows the train to continue, the control script will set the speed off, and as soon as the sensor for the next block goes, it will then start the whole process again for the next block. And this is just using, the control script just uses simple sort of if then else constructs. There's nothing particularly complex in it. The other thing I will mention very briefly, which I've shown in asterisks because it's not part of the example I've shown. I said right at the beginning that I didn't have detection of axles on trailing rolling stock. So in my actual script that I run, the config file also includes the length of the train. So what would happen is when a train passes from one block to the next, if it's hauling a load of stock, normally the signalling would change to indicate the block was empty as soon as the loco had passed, and obviously all the stock would still be there, so that would be incorrect. So what the script does is, if it knows what the length of the train is and it knows what the speed of the train is, what it will do is it will actually delay the reaction of the sensor by a time based on those two factors. So it sets what's called a debounce time for the sensor. So normally the sensor's active when the train's in there. You set the debounce time to say be 10 seconds. Train moves to the next section, but it won't actually release the sensor for another 10 seconds after it's passed, after it's left the section. So when you see the trains going round, it actually looks as though when the trail end of the train left that section, it then releases it. So it behaves just as though there was a load on the axle. And that is actually relatively easy to set up and works really well. Okay, so those are the principles of how it works. Just a couple of slides. I'm nearly done because I know I've been talking now for about an hour. So I will mention this because it's something that people always seem to ask about when I talk about this. Is how do you stop it? How can you stop a train accurately in the right place without having a stop detector? So this is the ideal case that we've already seen. So you have a train here. This light's amber. This one's red. So the train comes in, it's running at medium speed because the light's amber, gets into this section. As soon as it sees the red light, it will slow down to the slow speed and it will run for the set time and stop in the right place. So here, the second example underneath shows exactly the same track and set of signals, but a different loco. And the only difference is this one might have to run at 8% throttle, this at 14% throttle, because they react differently. But running it at a known speed for a known time should stop them both in the same place. So that's the ideal scenario that we've already seen. So what makes it not ideal? There we go. So here, the top example is exactly what we've just seen again, the ideal case, amber light, red light, and it stops. But what if the same loco going into the same block was stopped at a red light and had only just set off? So when it enters this block, it's running at a much slower speed. Maybe it's only just set off, so it's still running at just not much more than a slow speed. So if I now say run in this section for a certain time, it's not going to go as far. So this one, when it entered, was running at amber speed, at medium speed, and it slowed down and then stopped. Whereas this one was only running at slow speed when it entered. And therefore, if it runs for the same time, it's not going to go as far. So that's the first complexity you've got to deal with. And actually, it's relatively easy to do because you know what the speed is when it enters the section. If it enters the section at less than a medium speed, you basically add more time onto the time that it runs before it stops. And again, that is reasonably accurate. That works reasonably well, but that's one non-ideality that you have to cater for. The second thing you have to worry about is that locos don't respond in the same way. So the DCC decoder and loco combination, the reaction time is not the same between different locos. So when you tell a loco to stop, even if they were both running exactly the same speed and in exactly the same point, and you told them both to stop, they wouldn't stop in the same place, simply because the hardware in the loco won't react in the same way. So that's another non-ideality. And what I do to get around that is, you saw in the config file, I have a slow, medium, and fast speed defined, but I also define another fudge factor, if you like, which is a positive or negative figure, which is based on how fast that particular loco responds when you tell it to stop. So you can put in a tweak factor to balance out the fact that the non-ideal behavior of the hardware in the loco, and not all locos reacting in the same way. So that's another thing you need to do to make it to get the stopping accuracy. The final one, which is a really horrible one, is that locos don't run the same speed when they're cold. And typically I see about a 10 to 15% difference in speed between a cold loco and one that's been running for a while. Some locos it can be as much as 50%. Again, that means a loco that's nicely warmed up is going to stop in the right place. A loco that comes in and is cold is going to stop too soon. And this can be disastrous, because if the back end of the loco, if this was a long train and the coaches, for example, don't clear the previous points could change and it could all derail and go horribly wrong. So this isn't just cosmetic, it could actually cause derailments, collisions, and goodness knows what else if you don't get the locos to stop in the right place. But again, I compensate for this in the script. What I have is I've got a background thread running, which is actually monitoring how long each loco has been running for. And so if a loco hasn't been running for long, what I will do when it has to stop is I will add an extra delay to make it run for longer before it stops when it's cold. And as it gets warmer and warmer, that delay figure goes down until eventually it's fully warm and the figure's 0. So there's lots of non-idealities for that mean the locos don't stop where you want them to. It's a very difficult thing to get right. And finally, sometimes one day you come in and for some reason one loco suddenly decided it's going to run 20% faster than it ever has before, and you've no idea why, just because it's Thursday, who knows. Obviously you're going to get drift as well over time, particularly if it's a new loco and it's running in, you have to expect it's going to drift. But sometimes you do get these random changes, so it drives you nuts. So I would say in conclusion, I would only avoid putting in stop detectors if you really want the challenge of loading in all the workarounds, because it's very difficult to get accurate stopping if you don't have stop detectors. There's lots of things that make it non-ideal, and you can code around it to a certain extent, but it's never going to be 100% as good as having a stop detector. I did mention there briefly as well, I do have, to make this easier, I do have an auto calibration script. So basically to calibrate the locos, I've got a piece of track where I know how long it's supposed to take to get through that piece of track going at a particular speed. So I can just set the loco off and it just runs up and down through that piece of track, adjusting the speed itself until it gets to running. The delay through that block is as it should be. So that does make calibration a bit easier. I can just put the train on the track and go away and have a cup of tea, and it profiles it basically and sets up all the parameters for it. This is a screenshot of the actual operating screen with my scripts running. So you can see all the throttles at the bottom. It doesn't show the control panel. There's not room for that on the screen. You can see these are the threads running here. So there's 3 trains running and these are the routes they're running on. These are all the GUIs I've set up for setting up the routes and various other things that I want to do. I won't go through them all. Then these windows here basically show feedback information, which I built for the script to throw up. So this is showing all the locos, how long they've been running for, which is my cold running code. These show all the blocks and which block is occupying that block. So you can see, for example, D1005 is actually in 2 blocks here because it's in mid-transition from one block to the next. So it's occupying both blocks. And the 9 there, basically that is the debounce time. So it's moved from north to west to north to east. So it occupies both blocks. And this is just telling me that I'm holding the sensor for 9 seconds. Because that's what's needed for the rolling stock to pass and clear the section. And then this list here is showing all the point locks. So these are the list of all the points, and this is showing that DMU 101, for example, has got hold of 4 points at the moment and locked them, and D1005 has got hold of just 1. And you can see here as well, this is showing that this one's locked, and actually there's another loco waiting for that point. So there's like a queuing system as well to make sure when there's a log jam at points, they all go through in the right order. And that's about it. So I hope that made some sort of sense. So this is actually the live session underneath of the railway working now. So that's it. If there's any questions, I hope that made some sort of sense. It did to me when I wrote it. So.
Dave, we got Tom Houston with Tom Bailey with a question.
Yeah. Hello. Is he muted?
Tom, you're still muted. He might have walked away. Sorry. Shall we start with Sven then?
Yeah.
Yeah, thank you very much. I'm fascinated because I've been thinking about scripting and how to get started in it, and you're thinking in the same way as I'm thinking.
Sure.
A few questions. When you talk about locomotive characteristics, would you not use decoder CVs for speeds and run out distances?
I think yes. Some of the some of the decoders do allow you to set a distance. So yes, yes, that would be more accurate if you did that. If you had decoders that supported that, yes, yeah. So if the decoder can does support a stopping distance, then yes, yeah, that's true. Yeah.
Cheers. And you talked about YAT.
Yeah.
If you were starting all over again, would you use that instead?
No, because I wanted I wanted to do it myself in my own way. So yeah, and also, as I said, I wanted control over everything. So yeah.
Okay.
Yeah. So the YAT is quite different. I mean, it would make sense to look at that, and you could perhaps pick elements of it and reuse them and use the ideas in your own implementation. But yeah, I decided to go my own way. So.
And the last question: would you share your script files?
Yes, of course. Yeah.
Thank you.
So the examples there. Yeah. So there is a cut down example. There's a pan. I think there's a panel for that layout, and there's the configuration file and the script that actually runs it. So you can load that all in and use it. I think within JMRI you can run a simulated train as well. You don't have to actually physically have a train. So you could try it and run it with a simulated train, just as a point to start with. I'm not saying that what I've done is the best way to do it, and certainly not the only way to do it. And there are loads of examples on the JMRI website, which you can look through as well to get ideas. This is just how I've done it. So I'm not a programmer, so I probably haven't done it in an efficient or perhaps the best way. But it's from a sort of a casual user's point of view. This is how I presented it from a novice point of view, if you like.
Okay. Thanks a lot.
Okay.
Okay, we got one from Roger.
Hello. What sort of accuracy do you get on stopping point? You know, there must be a tolerance of how far is it plus and minus.
It depends really on the loco. Some locos are accurate to a very high degree, almost within, I don't know, less than a centimetre certainly. I mean, it depends on the loco and how well the loco behaves. Others I've had one or two locos that no matter what I do to them, I've just ended up selling them because they just won't behave consistently enough to stop accurately. So it varies quite widely, but normally within I don't know, just a couple of centimeters, I guess. I mean, it depends on your layout as well. I mean, because I've tried to cram as much as possible in, my longest train only just fits into my shortest section. So I have to be reasonably accurate. But if you had the luxury of some tolerance on stopping so that it didn't overrun or stop short, then you perhaps wouldn't need to be so accurate with where the stopping was. But generally, if the loco behaves itself, it's actually, once you've put in all the workarounds, it's surprisingly accurate. The one that's most difficult to get right is the slow speed running one, because it's so difficult to characterize a loco for how it warms up, the profile, how it warms up. But I've put it in because putting something in is better than doing nothing, and normally it's adequate.
And you've quantized your speed to sort of slow, medium, fast.
Yeah.
How much does quantization affect the stopping? You know, if you've got a situation where you're going from a previous block, but it may have been starting up from a red signal, it might have been traveling at full speed.
Yeah.
But presumably, there's a variation how long it's actually traveling, how fast it's traveling when it goes into the section. It won't be traveling at one of three speeds, it'll be some intermediate speed.
Yeah, that's right. So the compensation is based on a sliding scale. So it's not is it slow speed or is it fast speed? So if it was going in at slow speed, maybe I'd add 10 seconds. If it was going in at medium speed, I'd add 0 seconds. If it's going at halfway in between, I'd add 5 seconds. So there's an equation in the script that adds the delay based on the speed, And it can be any speed. It can be halfway between medium and slow, in which case it would only add half the compensation time.
And it's got some concept of time, so it can work out how long it's been accelerating before it changes section.
Basically what I do is I record the time. Every time a loco enters a block, I record the time, and then it's all timed from that point.
Right, and then it calculates on acceleration equations, yes.
Yeah.
Right, thank you.
Yeah.
Dave, I've got a few questions.
Sure.
Do you actually assemble any trains on the layout as part of the script?
No. Okay. No. The one thing that's my one thing I haven't done yet is fitted a and I do intend to do it, is put in a magnetic decoupler, so I can start playing around with that. But no, I haven't done that, mainly because the my first attempt to fit in the decoupling, I just ended up in messing up couplings and goodness knows what else, so I gave up with it and moved on and did other things. But at some point I'm going to come back to it. I ended up with super gluing couplings together and all sorts of things, so I haven't come back and had a go at that. I've actually been doing quite a lot of the modeling side recently, but yeah, I do intend to come back and add the automatic decoupler. That's still to do.
So you'll have to start messing around with the length of the train then when you start splitting it up.
Yes. Yeah. Yes.
The other thing is a general question, really. Did you have a plan of what you wanted to achieve before you started scripting, or did you just?
Yeah, I think so. Yeah. Yes, I did. Yeah. It was. Didn't I? It's kind of it's iterative, really, because you don't really know what you can do till you try and do it. So I guess I had the concepts there. Yes, yeah, that's true. And certainly the layout was designed from day one, as I said, to be for automation, so to have as much interest as possible. So
I suppose all the little add on this time and add on that time to get it to stop in the right places. You just discovering what it needs.
Yes, that's right. As you go along, yeah. I mean, as I say, I've been doing this for. I don't want to admit how many hours I spent trying to get it to run.
What other happens on Automation SIG stays on Automation SIG?
Yeah,
doesn't relate to the wives or anyone else.
And I will warn you as well, it is addictive as well. You come in and you just sit down first thing in the morning and think, oh, I'll just have a fiddle with that, and you're still there. You know, it's 6 o'clock at night and you think, oh my God, where's the day gone? It's totally addictive. Or I find it so anyway, which is a good thing, I suppose.
Do you set the top speed of your locomotives using the CVs? Do you adjust the top speed or just let them run at whatever?
Yeah, I do, because I use the speed ramp. I use the speed ramp in the CVs so that it just gives you finer control. That's all. So you get the right range. Yes, I do. Yeah. The other thing is I don't use any decoder momentum. So any acceleration or deceleration is done by stepping the speed in the script, not by relying on the hardware, because then I've got control of it in the script.
One last question, probably something you haven't done. It's up to now, you haven't mentioned it, and that is, do you have classes of trains which have priority over other classes of trains? Thinking of an express as opposed to a freight train. No,
I could do, but the problem is in a small layout you soon get a log jam if you're not careful. So you have to let everything run, really, otherwise it limits severely what you can do. I mean, that layout I can run probably 8 locos simultaneously, probably, on that layout. Any more than that and you start to get a log jam. But yes, you could do the priorities. The only priority in there is basically the queuing system for the control of points. So you don't get one loco that just sits there forever waiting for a point and not getting it. It knows it's next in the queue and it gets the next bite at the point. One other thing I forgot to mention is quite important. It took me a long time to resolve this. As the scripts were developing, everything was going fine. I could run several trains at once. But if I tried to run more than about 3 or 4 trains at the same time, I found that everything would suddenly stop, and all the locos would just sail on at whatever speed they happened to be running, and then it would all go horribly wrong, or everything would collide and derail, and the whole thing would just shut down. There'd be no communication with the locos at all from JMRI. It would just stop, and it seemed to be a certain level of activity, and then the whole lot just shut down. And I'm pretty sure what it is, because again, it's been on. There is a thread on this on the Merg thing forum. Is when I was running the trains, all the scripts, when I was running multiple trains, they could all be firing off commands to the CAN command station, but there was no synchronization. So all the trains could be sending a whole load of chatter to the command station all at once. And basically it was swamping the command station. And if you send the command station too much traffic in too short a period of time, it just stops working. Very easy fix to that. What I do now is I've just got a queue. So if a train wants to change speed, what it does is puts a request in a queue, and the queue is running as a background process, and it just fires off a command to the command station every 30 milliseconds. So the command station now gets all its commands in a measured way, and now I never swamp it, and you can run, the capacity then goes, it is much better. I believe the CAN command 2 is improved in terms of handling traffic compared with the CAN command, but it's not a problem. That you can use the CAN command, it works fine, provided you send it all the commands in a measured queue. But if you try and send it too many instructions all at once, it just seems to shut down. So just be aware of that. It took me a long time to find out that's what the cause was, because I didn't know where the problem was, but that's where it was.
Okay, Tom Bailey's back with his question now.
Sure.
Yeah, Dave, did you do all your configuration for your actual CBus network in the FCU, or do you have confidence that you can do that independently now in JMRI?
Sorry, I'm not sure I understand the question.
Well, there's access to CBus, or being more and more access with JMRI, and some people are talking that you could actually bypass configuring your CBus network using JMRI.
I see. Okay, no, I haven't. I wasn't aware of that. I hadn't seen that. No, I use Flim to program all the CBus objects, and then use the tables to map that object to map that CBus event to the JMRI object. So no, I wasn't aware it had gone that far. Yeah, I know there's some new developments as well. Use things like there's a current meter now. So you can see the supply current taken by your controller, and there's all sorts of things, more and more things going into JMRI all the time for Merg.
Yeah, I wasn't sure that you could get there yet, and I've heard people have not gotten comfortable enough to do all the configuration, so there's a lot of people are doing it.
No,
so
I haven't tried. So.
Okay, thank you.
Okay.
Are there any more questions for Dave?
Yeah, I've got one actually. Do you get any time lag when you initially fire up your scripts, as there are lots of them?
Do I get any time lag? No, there is a response time from the hardware and everything else. But no, it's not really that significant.
Okay.
It's manageable. The one thing that you do need to be careful of, particularly with the turntable, is that because obviously there is a response time from the sensors on the turntable, so you make sure that you run the locos slow enough that they don't whiz off the end of the turntable before they can react, because when the sensor goes inactive, as it leaves the radial and goes onto the turntable, there is a delay before it goes through the system and JRI and back to the throttle and says stop the loco. The loco could be off the other end of the turntable before you'd sent the command to stop. So you just have to make sure you run it slow enough that doesn't happen.
Yeah, it's just I've gone down the YAP route, and obviously because that works on text files, if you're loading 15, 20 loco routes into your program,
right,
there's a fairly big time lag, probably of 2 or 3 minutes right at the start.
No, nothing
It
like
chews
that.
its way through all the scripts.
No, the scripts run very, very quickly. No,
Yeah.
I don't see any time lag at all, no.
I think that's probably one of the pitfalls of converting it to, as you were saying, plain English.
Yeah.
And it has to process all the text files
Yes. Yeah.
before it starts up.
Yeah. Yeah.
Yeah. Okay.
Okay, are there any more questions for Dave? Dave, have you got any future plans for the layout that we might be able to follow later on?
I suppose the decouplers, modelling side, I can't add anything else physically on the board. I think I've rammed everything I can on there, so I can't add any more to the layout. I'm constantly revisiting the code and tweaking it and improving it, and I've had probably 3 major iterations, and as it's developed, and the problem is as it develops, if you don't know everything at the beginning, it becomes a bit of a monster to manage. So I've had several sort of start and rewrite again. So I'm probably going to go through that exercise at least one more time, I would think, and do a complete rewrite, but it's probably going to be using pretty similar structure. The one thing I will say is if anybody wants to come and see the layout and play with it and look at the scripts, I'm quite happy once COVID's over, if people want to come and have a look. I'm based in Swindon, so if anybody wants to do that, then I'd be happy to host people to come and have a look and play with it and run the trains and see how it all works firsthand.
Might be next summer by the looks of it.
Yeah, possibly. Yeah. There's also the you've got the Great Railway Steam Museum in Swindon, and also the Swindon and Cricklade Railway. There's a heritage railway as well, so it's quite a few things to come to Swindon for. Make a day out of it.
Yeah. I can see a bus load coming up there from various places throughout the country.
I've got a question for being a newbie with similar aspirations to doing a control system. What train on track indicating system are you using? Because there's been a lot of threads on the Merg layout with all different sorts and the different ins and outs.
It's I use the DCC8 detector with a CAN ACE 8. What's it called? ACE 8C, I think it is, which then takes the outputs of the DTC8 and feeds it onto the C bus. So there's 2 boards that work in tandem, and I find that works very reliably. The other.
Thanks for that. I'm in Cairn, so it's not far from Swindon.
Okay, yeah, sure, very nearby. Yeah. The other thing I did actually, because thinking ahead, because I have at least one a dropper on every track and don't rely on joiners. But what I did because I didn't know at some point whether I might want to implement stop detectors. When I laid the track for the section, I actually put an extra set of droppers near the end of the section where the signal mast is. And then that gives me the option at a later date of snipping the track and connecting those 2 droppers to another block detector. So I could, if I got really fed up with not stopping trains in the right place, I could at a later date use a block sensor as a stop detector. So I built that in when I built the layout to give me the option to do that.
That's quite interesting, Dave. I'd already planned that next meeting in November we'll be talking about block detection,
sure,
and sensors within blocks and where they should be put and how many you should have, if any. And I'm hoping to do a quick presentation at the beginning of the next meeting, and then for a big discussion to go on, because I'm pretty sure amongst all of us we would all have different approaches. And it'd be interesting to see what other people have been doing.
Sure.
It's true that in many cases you just got current detection and you're just using the scripts to find the correct position to stop, or do you actually have any spot detectors at all anywhere?
No, there's no spot detectors at all. No.
Okay.
It's all block detectors, and the DTC8s have been 100% reliable. They're really very good. That's the other thing when you're scripting is you have to have the hardware 100% set up. It has to be 100% predictable and reliable for the scripting to work properly. And the merge side of that has been very good. Where I have the problem usually is with the locos just not behaving, and I find I'm in Engage, and the motors burn out at the drop of a hat. I've lost so many motors, I can't tell you. Probably about half of the locos over a period of 4 years. I've had to replace the motors because they just go pop. How
many turns on a DTC8 coil? If you
2, I think. I can't. 2.5.
Is that just to make it a bit more sensitive for the Engage?
I can't remember that. It was a long time ago since I did that, but I think that's what was recommended.
Right, that's a standard one.
Dave, when you talk about the reliability and N scale, I find a lot of problems where the trains are jumping up and down a bit, and you get a bit of jitter. Do you have any problem with that?
Not so much jitter. I mean, the problems I have with mostly it's the locos not running at a constant speed or a predictable speed. That's the worst problem for me.
Or the problem where the train loses contact when it's stopping and then it doesn't get started again.
Okay.
It's not seen by the detector.
Yes. Yeah. No. Normally that's okay. I'm going to find that okay.
Or maybe your tracks are cleaner than mine.
Yeah, I don't tend to have too much problem with that. Most of my points now are Electrofrog. I've got a mixture of Electrofrog and Insulfrog. Electrofrog is better for sure. I don't have that much problem with Insulfrogs, but Electrofrog's definitely worth doing. It makes it so much better. It's 100% reliable.
Okay, thanks, Dave. That's been very good. Everybody who's left so far has been impressed. It's been a good introduction. Are you going to be able to make the presentation, the PowerPoint presentation?
Yes, I can do that. I can make the presentation and the example scripts. I can show you. I'm quite happy to post my full scripts if you want as well, but they're a bit convoluted. But you might grab something from it. But as I say, I would also recommend strongly looking on the JMRI website. Look at the examples on there, and things like the YAT, because that's really very complex piece of code, way beyond anything I could produce as a non-programmer. I'd say my control scripts are basically just if then else. They're not. There's nothing complex in there. They're just if this happens, then do this, basically, and that's enough. You can run the layout with that, I find.
The things I've found in control engineering is the simpler it is, the more reliable it is.
Yeah, that's the other thing I found. I have done some scripting in the past, but it's been with fixed data sets. This is the first time I've tried to produce a script for a control system, and a control system is very different because you're not working with a fixed data set. The controls, the real world will do whatever the real world does. So you don't know what it's going to do. There's all sorts of scenarios that pop up that you don't think of. When you're working with a fixed data set, you know what you're working with. When it's a control system, it's really difficult to know what all the inputs are going to be to the system because it's the real world, and it's very different trying to write a control system script to what I've been used to in the past. So.
Okay, thanks, chaps. I think we'll call the meeting to a close now, if that's okay.
Sure, yes.
Thank you, Dave. That's been very, very good. And just what we needed at this time. Perhaps less controversial than Michael's last one, but I'm still pursuing down the Railcom route to do some testing. So after that, it will be JMRI. So thanks very much for getting us all infused again.
Good. Okay, hope it was useful.
Yes.
Okay, thank you. Bye.
Thanks.
Thank you very much.
Bye.
And we'll convert you to C+ eventually, Paul.